Hello everyone, how are you all doing today? Welcome to my new video. In this video, I'll show you how to integrate functions involving square roots in those. Most people get scared when these square roots, especially inside of an integral, but you should not get scared. I'll show you the exact technique via which integrals like these just become smooth as butter. So make sure you watch this video till the end. Also, if you are new to my channel, I want to inform you that I do post math and calculus content like this every single day. So if you don't want to miss a similar content like this in future, please do consider to subscribe to this channel. Alright, let's get into the video. Whenever you see a square root inside of an integral, what you have to do is you have to rationalize that square root expression. And what we mean by rationalizing is you have to multiply and divide by the conjugate of that expression. Let's see how do we do that. So what we do is you multiply and divide. So first let me write that expression 1 over square root of x plus a plus square root of x plus b, and then you multiply and divide by the conjugate. The conjugate of this is you just put a negative here instead of a positive, and you multiply and divide by that. So you have x plus a minus square root of x plus b, divide by the same thing in order to nullify the effect of that expression. So you have to multiply and divide by the conjugate of this expression whenever you see a square root inside of an integral. After that, what you have to do, what you can do here is you can, in the denominator, apply the formula a plus b, a minus b, because we know that a plus b and a minus b, a plus b times a minus b is nothing but a square minus b square. So what you can do here is you can apply that formula in the denominator, and in the numerator you'll just have this expression because this times 1 is nothing but the same thing. So you'll have integration of square root of x plus a minus square root of x plus b divide by, and you have a plus b, a minus b is nothing but a square minus b square. So you have square of this. So when you take a square of this, the square root will get cancelled. So you will have x plus a minus b square, and when you take a square of this square root will get cancelled. So you have x plus b. I hope that makes sense. I apply that formula a plus b, a minus b in the denominator. All right, now let's see how do we simplify this. You can just multiply this minus inside of that bracket. So you have integral of square root of x plus a minus square root of x plus b divide by x plus a minus x minus b with respect to x, and that minus x and plus x will get cancelled at this point. Okay, now what you have left in the denominator is a minus b, which is a constant value, can be taken out of the integral. So you have 1 over a minus b, which is the constant value, taken out of the integral, and you have in the numerator left over square root of x plus a minus square root of x plus b with respect to x. Now this is a simple algebraic integral. What you can do is just give the integral to both of those terms. So you have 1 over a minus b. Let me open up a box bracket, and you have integral of square root of x plus a with respect to x minus integral of square root of x plus b with respect to x. Let's close the bracket. Now we know the basic algebraic formula of integral. We can say that we know that integral of x to the power n with respect to x is nothing but x to the power n plus 1 divided by n plus 1 plus constant of integration c, of course. So we can apply that same algebraic formula over here, and let's see what do we get. So we have already 1 over a minus b outside of the bracket. Now square root of x plus a. Now square root is just like to the power half. So this square root of x plus a, this is just like x plus a to the power 1 by 2. And even this x plus square root of x plus b, this is just like x plus b to the power 1 by 2. So we can just apply this formula and say 1 by 2 plus 1 divide by 1 by 2 plus 1. So you increase that power by 1 and divide by the same power. So what you get here is x plus a, because we have x plus a to the power 1 by 2, we get x plus a 1 by 2 plus 1 divide by 1 by 2 plus 1 minus x plus b to the power 1 by 2 plus 1 divide by 1 by 2 plus 1, and let's add the constant of integration c, and that's really your final result. We can clean this up a little bit and say we have 1 over a minus b. Now half plus 1 is nothing but 3 by 2, so we have x plus a to the power 3 by 2 divide by 3 by 2 minus x plus b to the power 3 by 2 divide by 3 by 2 and plus constant of integration. See, and you can call this your final result of the integral that we are looking for. How easy was it to solve such square roots inside of the integral? Remember, whenever you see a square root inside of an integral, you have to rationalize that square root. And by rationalizing, what do we mean is we have to multiply and divide by the conjugate. If you found this content useful, please do consider to like this video and subscribe to this channel. Again, I want to remind you that I do post math and calculus content every single day. So if you don't want to miss daily videos, please do consider to click on that subscribe button. This might be your only chance to score full marks in your upcoming calculus exam. I'll see you tomorrow.